Okay, let's look at these questions that you have asked me. Alcohol density is given to you. They say you're going to fill it halfway, a cylinder that can measure 150. So you need to know that we are only going to fill it half filled. That means the total volume you should think of now is only 75 cm cubes, not 150, but half of it. Okay. So when they ask for the mass is to take the density with 0.8 multiplied by the volume. This is how you get the answer. So I think you were careless. Those of you who got this wrong, I think you're careless. Answer should be A. Okay. Getting this, all of you? Okay. Move on to the next one. This one is also a trick question. Listen, this type of question always appear. Always appear. Do not forget that you are dealing with the same cake. It doesn't matter if the cake is big or small. The density will not change. There's nothing much we could do here. It's like a trick question. You understand? Remember we said before that if it's the same material, the density is the same. That is why you cannot do the last question just now. Okay. So, okay, let's move on first. Later we'll talk about that. Now, this one, I want to spend some time and remind you, this is a very common question. Be very careful. The units from gram to cm cube, you need to know how to convert this to kg per meter cube. Because this is a very standard conversion, they always ask this. In other words, you just simply memorize the outcome. Multiply whatever number you see here by 1,000. This is how you convert it to kg per meter cube. This is like the magic number you need to remember. And if they want you to convert it backwards from kg per meter cube to gram per cm cube, then you just divide it by 1,000. So the magic number here that you need to memorize is this number, 1,000. Whether to times or to divide, you must also remember. Okay? Later towards the end of the lesson today, I will show you the reason why this 1,000 works. But we keep it simple first for now. Okay? Copy this, I pause the recording here. Okay, 41. Which of the following changes takes place when a fixed mass of air is heated in a hot air balloon? I'm sure you roughly understand what a hot air balloon can do, right? It's going to rise higher and higher up. So what do you think is the density of the hot air balloon? For it to keep rising upwards, that means the density must be lesser than the surrounding, which is air. Okay? When you heat the hot air balloon, what is the air inside the balloon going to do? In primary school science, what did you learn about objects that is being heated? What happens to the volume? When you heat things up, the volume increases. So you must be able to think of the volume increasing. But because they told you that the mass is fixed, what do you think now happens to the density? The formula for density is the mass over the volume. So if the mass is fixed, but I make the volume larger, this is like making the denominator larger. I show you some basic numbers to prove to you. Think about 1/3. And if I keep the numerator the same, but I make the number below smaller, tell me which number is bigger? Is it A or is it B? Which number is bigger, 1/3 or 1/300? 1/3. So what can you conclude about the denominator when it gets larger? The overall number becomes smaller. Understand? So if the volume gets larger and larger, the density decreases. Decrease. This is using mathematics to appreciate what's going on. There's another better way, I think, which I always say to you guys. What does it mean when the volume gets larger? it means that there is now more space. When there's more space, but the amount of particles you have is still the same, don't you agree it's less packed, no? It's less squeezy. When it's less packed, less squeezy, the density drop. Because density, after all, like I said, is like the packing. How much packing you have determines your density. Remember that statement, the first lesson I teach you? Okay? All good? Okay, then I move on. 45. So you must remember the difference between mass and weight. I mentioned that in my lesson as well. Weight can change because weight is dependent on gravity. Weight is dependent on gravity. Okay, your mass is always fixed. The mass will not change. So look at statement A. What is wrong with statement A? When they describe the mass of an object, do you use the unit called Newton? You don't. Newton is to describe the weight. So be careful. Is this okay now to use kg to describe mass? This is okay. This is okay. And do we measure mass using beam balance? The answer is yes. So this is theory. This is theory stuff you need to memorize. Mass is measured using beam balance. So please take note of that. Beam balance, we use this to measure the mass. If you didn't know this, you must copy this. Then what about the spring balance? Spring balance is to measure weight. Okay, weight is also a type of force. So spring balance can also be used to measure your force as well. Okay, I give you this, you copy, I pause the recording here. Okay, this one I want to talk about it. Guys, I keep stressing the fact that the units can tell you a lot of things. Really, look here. This unit is telling me 1.6 Newton per kg. Let's go back to something simple. What if I tell you something like this, $1.6 per fish? I'm sure you know what this means. Every fish costs $1.60. So what does this mean in other words? This means that every 1 kg is going to be 1.6 Newton. This is what it means. Understand? What if you have an object that is 30 Newton? Now, you notice they use the word on Earth. So this is the tricky part. Earth has its own gravity value, and the moon has its own gravity value. This is the value of the gravity on moon. You need to know, I think it's good to know that on Earth, the value is 10. I mentioned this before to you when I teach you how to convert mass into weight. I mentioned to times 10, right? Remember the lesson when I say times 10? Times 10 because this is the effect of gravity on Earth. So you're supposed to remember this value and use this to find out what is the mass first. So I give you an example. So based on this, I know that every 1 kg is 10 Newton. So if I have 30 Newton on Earth, can you tell me how many kg will this be? Think about this logically. How many kg will this be? How much? 1 kg is 10 Newton. Now I have 30 Newton on Earth, which is how many kg? 3, right? All of you agree? Now this 3 kg is the mass. And can the mass change? The mass cannot change. So you're going to take this mass, 3 kg. If you go to the moon, can you calculate what the weight will be on the moon? You take 3 times 1.6. And then now you get 4.8. Can you understand what's going on? Okay, copy this. This is an important question. Pause the recording. Okay, so for this last one, you must remember, right? Even when the question says that it is broken into 2 pieces, there's one thing about the object that doesn't change. You know what is that? The what? The density. So the smaller piece is 650 grams. Knowing that this is 1.5 kg, which is a total of 1,500 grams, then can you conclude this will be how many? 850 grams. They're asking you for the volume of the larger piece, but we know that the density of the larger piece is still going to be 2,400. Now, the issue here is the units, guys. You notice that the answer finally is in meter cube. It's in meter cube. So you may want to use the kg per meter cube. That means to say that this density, you want to keep it as 2,400 kg per meter cube. But because this is in kg, you want to change this to kg. You all know how to change 850 gram to kg, right? So you want to keep this at 0.85 kg. And using this to find out the volume. The volume will be the mass over the density, which is 0.85 over 2,400. So this will be a very small number. That's why the answers are all in standard form. Press a calculator and then see what is the value. Understand? I want everybody to be able to press a calculator and figure out what to choose. Okay. So this is where the things I teach you about significant figures and standard form comes into over here. Okay, stop the recording here.